So what we have discussed till now is in the frequency response. In the frequency response, so we have discussed, let's say, how to find amplitude ratio and phase angle or variety of systems. See how to find the amplitude ratio and phase angle is just put s equal to j omega, translate into a plus ib from root of a square plus b square is nothing but the amplitude ratio, phi is the phase angle. Clear? So that is the concept. Now, what is the objective of this chapter is to check the stability of the system. So how do you find stability of the system is from the amplitude ratio and phase angle. Now the concept of Bode plots. So what is the concept of Bode plots is there are two types of Bode plots. One is phase angle Bode plots, another one is amplitude ratio Bode plots. Amplitude ratio Bode plots. Let's take the transfer function 1 by tau s plus 1. So what is the amplitude ratio for this transfer function? One by tau square plus omega square. So what is the limits of omega and tau? So what is the limits of omega tau is minimum it can have a value of 0, maximum it can have a value of infinity. So now let's say from this transfer function omega tau is less than 1. Omega tau is almost equal to 0. Then what happens? Your amplitude ratio is equal to 1. When omega tau is greater than 1, that means omega tau is almost equal to infinity. Then what happens to your amplitude ratio? 1 by omega tau. So you have amplitude ratio 1 and amplitude ratio equal to 1 by omega tau. So these are the 2 points. So we will discuss the significance of Bode plots in the next topic. What is next topic is you use these Bode plots to define the stability of the system. Now, if I draw a plot of, let's say, amplitude ratio versus omega, maybe I'll draw it on the next board. If I draw a plot of amplitude ratio versus omega tau, suppose I'll divide this entire graph into two regions, 0 to 1, 0, 1 to infinity. So, do you know the concept of asymptote? What is an asymptote? Asymptote. What is an asymptote? Definition of asymptote. So, let's define what is asymptote first. Asymptote. We have the concept of this asymptote, which is called as tangents at extreme points. Tangents at extreme points are called as the asymptote. Suppose if I have a curve something like this, if I have a curve something like this, then let's say this is my minimum point, this is my maximum point. So this is one asymptote and this is one asymptote. So tangents at extreme points are called as the asymptotes. This is one asymptote, this is second asymptote. Definition of asymptote is tangents at extreme points are called as asymptote. Now let's take this graph. So you have two asymptotes. The curve may be something like it. Some you don't know, but you have the asymptote. What is the nature of this asymptote? When you are in the this is one extreme point, another one is this is an extreme point. So this is one asymptote. AR is equal to 1 is one asymptote. AR is equal to 1 is one asymptote because you see the behavior here. When omega tau is less than 1, the AR is equal to 1. When omega tau is greater than 1, AR is equal to 1 by omega. Let's say log AR is equal to minus log omega tau. And if you are plotting this on a log-log graph, so this is log-log graph. So what is another asymptote? This is the another asymptote. This is the another asymptote, which is omega. This is one another asymptote. The actual curve may be something like this. I am not interested in the actual curve. The actual curve may be something like this. So this is the actual curve. This is the actual. This is the actual curve. So you have two asymptotes. This is another asymptote. But remember, when you are in this region, this asymptote has no meaning. When you are in this region, this asymptote has no meaning. So this is what is asymptotic plot of AR versus omega tau. Basically, log AR versus log omega tau. Yeah, if this log value should be 0, but this is what is log graph? You mark the actual values, but the nature of the graph will be like log. Log doesn't mean that you will log it as 0. You will mark the actual values only, but the scale is calibrated to log scale. Now, next point is, can you translate log AR versus log omega tau to log AR versus log omega? So can you translate this graph to log AR versus log omega? So just what happens is, this is omega, this is 1 by tau. When it becomes 1, it becomes 1 by 2. This is 0 to infinity. So you will have basically two asymptotes. One asymptote, another one. This asymptote. This has no meaning. This has no meaning. This is 1. This is amplitude ratio. This is omega. This is what is called as the Bode plot. This is what is Bode plot. Basically, what is definition of Bode plot is asymptotic plot of log AR versus log omega is called as Bode plot. See, so how to draw the Bode plot again? So Bode plots will be different for different transfer functions. Let's take 1 by tau s plus 1. Then what is amplitude ratio is 1 by root of 1 plus tau square omega square. Then what is the limits of omega tau is 0 to infinity. So when omega tau is, let's say, less than 1, then our amplitude ratio is equal to 1. So that means when omega tau is almost equal to 0. When omega tau is greater than 1, so that means your omega tau is almost equal to infinity. So that means when omega tau is almost equal to infinity, our amplitude ratio is equal to 1 by omega tau. So our log amplitude ratio is equal to log minus log omega tau. Now if you plot a graph of amplitude ratio versus omega tau, so then we have understood the concept of asymptotes. What is the asymptotes is tangents at extreme points are called as the asymptotes. So this is one tangent and this is one tangent. So let's take this curve. So at the extreme points, this is one extreme point. Another one is this is one extreme point. So you have two extreme points. So tangents at extremes are called as the asymptotes. Now, if you draw this curve, so we'll have 2 points. When omega tau is, this is one extreme point, this is one extreme point. So at this extreme point, the curve behavior is AR is equal to 1. I am drawing it on a log graph. So on log graph, your actual values will mark it. But the graph will looks like log x versus log y. You don't plot log x directly. You will plot x versus y only. But the graph looks like log x versus log y. So then you have two asymptotes. AR equal to 1 is one asymptote. AR equal log AR equal to log minus omega tau. So I equal to minus mx. Y equal to mx. Slope is minus 1. So what is the slope of this line is minus 1. Slope. Clear? So now in this region this asymptote has no meaning. In this region this asymptote has no meaning. So that is log AR versus log omega tau. See what we have drawn is the asymptotes. Now if we translate this Krivin graph log omega tau to log AR versus log omega, then this is the graph. This is called as the Bode plot. What is the slope of the line here? Slope of the line is minus 1. This is for 1 by tau s plus 1. Can you draw for Kp by tau s plus 1? Take the Kp by tau s plus 1 and draw the Bode plot. sorry. So the transfer function is kp by tau s plus 1. So what is the amplitude ratio is kp by root of 1 square tau square omega square. Then when omega tau is less than 1, amplitude ratio equal to kp. When omega tau is greater than 1, amplitude ratio equal to kp by omega tau, and you take log scale. Now, so it will start from kp. So now if we translate this into the actual Bode plot is log omega, and then this is what is 1 by tau, 1 by tau. So this is one asymptote, this is another asymptote. Infinity 0. Yeah, starting point is kp, and this is omega. This is omega. So in Bode plots, what is the slope here? -1. So here you having this intercept also is there. This intercept which is log kp, log kp, log kp. But we are not interested in the intercept because in this region this asymptote has no meaning. So the major difference is the entire Bode plot will lift by kp units. The entire Bode plot will lift by kp units. So slope is -1 only, no? Because minus log omega tau. Blue line will intersect at log kp, log kp values. See in the Bode plots where the slope changes. So here 1 by tau is the one where slope changes. This is called as crossover frequency. This is called as crossover frequency. The slope at which the frequency at which the slope changes is called as crossover frequency. The slope at which, or the frequency at which slope changes. 1 by s plus 2. Can you draw the Bode plot? 1 by s plus 2. So can you draw the Bode plot? This Bode plot slopes is an important question. So first thing is translate this given 1 by s plus 2 into a standard transfer function. What is standard transfer function? Kp by tau s plus 1. So when you translate this one, 1 by 2 by s by 2 plus 1. Now, what is the Bode plot? So what is crossover frequency? Sorry, this is corner frequency, not crossover frequency. Just give me a minute. So whatever we told, this is not crossover frequency. Crossover frequency will come in the Bode stability criterion. Just give me a minute to check it out once. The names are confusing sometimes. Yeah, this is corner frequency. Crossover frequency will come in the Bode stability criteria. Change this one. This is corner frequency. So what is corner frequency? 1 by tau. What is tau here? 1 by 2. So which is 2. 0, 2 and infinity. Clear? Now amplitude ratio and omega. This is what is Kp. What is Kp is 1 by 2. What is another asymptote is? This is another asymptote. This is the Bode plot. So can you draw Bode plot for, let's say, 5 by s plus 4? Can you draw Bode plot for 5 by s plus 4? Yeah, corner frequency is always 1 by tau. Yes, corner frequency is always 1 by tau. So what is Bode plot for S by 5y? If you translate this into standard form, what is the standard form? 5 by 4, 1 by 4s plus 1. Tau is 1 by 4. What is 4? 4. So you have 0. This is 5 by 4. This is amplitude ratio. This is frequency. Once again, it is on log graph. Problem in the Zoom, it has disconnected. So I'll just draw the Bode plot again. What is this? Is 4 by 5, 4, 0, infinity. This is omega. This is amplitude ratio. Okay. So this is 5 by 4. So here the gate question is like this. 0 less than omega less than 4, slope is 0. 4 less than omega less than infinity, slope is minus 1. So yes, we have variety of models. Can you draw Bode plot for tau s plus 1? Can you draw Bode plot for tau s plus 1? We have variety of Bode plots. So tau s plus 1, kp into tau s plus 1. Let's say if we have big transfer functions 1 by, let's say 2s plus 1 into s plus 1, or s by 2s plus 1 into s plus 1, 1 by s into s plus 1. So all this will come. Root of 1 plus omega square tau square omega less than 1, amplitude ratio is equal to 1, omega tau greater than 1, amplitude ratio is equal to omega tau. What is log amplitude ratio is equal to log omega tau. So if you plot, directly I am plotting the Bode plot. So at the corner frequency 1 by tau, this is y equal to x, positive slope. This is one asymptote, another one is this asymptote with a slope of plus 1. So this is 1. Clear? So this is one asymptote, another one is this asymptote with a positive slope of plus 1. Infinity 0. This is amplitude ratio. Suppose if I put, let's say, kp into tau s plus 1, this 1 will be replaced by kp. So nothing will change. Slope equal to plus 1, no? Because this is y equal to mx. What is m plus 1, no? Log. What is the transfer function? What is the transfer function? So this is Kp 10 into tau s plus 1. Basically, this is Kp into tau s plus 1. What is Kp is 10. What is tau is? This type 10 is 1 by tau. What is tau equal to? 1 by 10. So 10 into s by 10 plus 1, which is s plus 10. Let's try multiple transfer functions. 1 by tau s plus 1 into 3s plus 1. So here what we do is, so we will plot 1 by 2s plus 1, 1 by 3s plus 1 separately. Let's take corner frequency 1 by 2 and 1 by 3. So let's plot them. This is 1 by 2. This is 1 by 3. This is infinity. This is 0. So what is 1 by 2s plus 1? Sorry, this is reverse. 1 by 3 will be first. 1 by 2. 1 by 3. What is 1 by 3s plus 1? What is the slope here? Minus 1 slope. So this is 1 by 2s plus 1. This is 1 by 2s plus 1. So if you combine these two, then what happens here is, what is here overall amplitude ratio? AR1 into AR2. What is log AR? Log AR1 plus log AR2. Here also slope minus 1. So when we are plotting, let's say, overall graph, the overall graph will have a 1 here. Then it starts to decrease with a slope of minus 1. Then it is going with a slope of, let's say, minus 2 here. Slope of minus 1 and slope of minus 2. Minus 1 and minus 2. Because some slopes are 0, no? So if I write, let's say, what is the slopes? So if you write slopes summary, 2s plus 1, 3s plus 1. So what is 2s plus 1 is? 0, 0, minus 1. What is 3s plus 1 is? 0, minus 1, minus 1. So what is the overall sum? 0. What is the overall sum? Minus 1. What is the overall sum? Minus 2. Clear? So the overall sum, or let's say overall slope, is sum of individual slope, because the overall amplitude ratio is sum of individual amplitude ratio. Just observe this one. And so do you have any doubts here? Any doubts here? So here, what is important point is, so when you write the summary, 0 less than omega less than 1 by 3, slope is 0. 1 by 3 less than omega less than 1 by 2, slope is minus 1. Omega is greater than 1 by 2, slope is minus 2. So this is the gate questions. He will give the range of omega and he will ask for the slopes. See, it is nothing but addition of slopes. So because here, what is 2s plus 1? 2s plus 1 has 0 slope here, 0 slope here. Because when 1 by 2 is there, it changes to slope minus 1. 3s plus 1, 0, minus 1, minus 1. Later on, it changes to slope minus 2. Can you try 2s plus 1 by 3s plus 1? And 3s plus 1 by 2s plus 1, both. What are the Bode plots for both? What is 2s plus 1? So don't write log r, all these things. Simply, how many corner frequencies? 1 by 2, 1 by 3. This is 1 by 3. This is 1 by 2, infinity. Now, 2s plus 1, 3s plus 1. 2s plus 1, 0, 0, plus 1 slope here. 3s plus 1, 0, minus 1, minus 1. So when I am plotting the overall, what is the overall slope is 0, and then minus 1, and then 0. What is overall? 0, minus 1, 0. So, so what is the slope here? Same 1 by 3, 1 by 2. But here if you see, 2s plus 1 is in the denominator. So 0, 0, minus 1. So what is 3s plus 1 is in the numerator. 0, plus 1, plus 1. So it starts like this, it goes like this, it goes to 0. So what is the overall slopes here? 0, minus 1, 0. So 0, plus 1, 0. What is S into, or let's say 1 by S plus 1 whole square? What is the, or let's say 2s plus 1 whole square? So like take 1 by 2s plus 1 whole square. So here you have two corner frequencies, 1 by 2 and 1 by 2. Minus 2 slope because 2s plus 1 2 times. 0, minus 1, 0, minus 1. What is 1 by S plus 1 whole square? S by S plus 1. Can you try the transfer function here? Or let's say just try for 1 by S first. Simply 1 by S and S. One by S. 1 by S. So what is the amplitude ratio? Simply 1 by omega. So here earlier if you see 1 plus is there, that is why we have taken two regions. Here there is only a single region. So what is this one is log AR is equal to minus log omega. So if you try to draw Bode plot, you are starting 0 to infinity omega. You have only one asymptote. You don't have two asymptotes. Directly minus 1 from 0 to infinity. So similarly, what is S? Here amplitude ratio is equal to omega. Log amplitude ratio is equal to log omega. final transfer function which has all the things. I think before this one, let's solve one transfer function. Can you draw the Bode plot for this one? So what is the amplitude ratio of e power minus s by 2s plus 1, which is equal to amplitude ratio of 1 by 2s plus 1 into amplitude ratio of e power minus s. What is amplitude ratio of e power minus s? 1, no. So this e power minus s has no effect, Bode plot. E power minus s has no effect on the Bode plot. Hence, there is no effect on the because it has no effect on basically amplitude ratio. That means it has no effect on the Bode. So just last one, which has all the effects which we have done till now. If so when you have only S, the corner frequency is directly 0. Assume that it has 0 corner frequency. So what are the corner frequencies? Is 0, 1/2, 1 2 times, and 10. Now, just mark the corner frequencies. 0, 10. Yes. In the denominator, -1, -1, -1. So S plus 1, 0, 0.5 S plus 1, 0, 0, plus 1, plus 1. 0.1 S plus 1, 0, 0, 0, -1. So basically it starts from 10. It starts with a slope of -1. It goes with a slope of -3. It goes with a slope of -2. And then because S plus 1 has come 2 times, no? S plus 1 whole square, that is why. I think we'll close it now. Tomorrow morning I will take the class. Because you said that you do not have FM class. Maybe I will start from 7 up to 8:30 I will take. And tomorrow evening also we will take. So that tomorrow we will complete the frequency response. Tomorrow 7 to 9:30. I will ask them and send them if it is convenient, and I'll ask them to send the message. So tomorrow I will complete the frequency response. With that one, most of the syllabus is done, 90%. 10% which is remaining is chapter 2 and chapter 5, which will take 2-3 classes. And then later on, tomorrow you will get the message, timings. What is the use? I will teach you in the stability. How to find phase angle Bode plot? So tomorrow we will start with the phase angle Bode plot. So what is the phase angle of e power minus tau d? S is minus omega tau d or minus 57.32. Yeah, instrumentation I'll take at the end one class. S plus 1, how slope is minus 2? I think you were asking the same question multiple times. So I told you, because this is already answered, because S plus 1 has come 2 times, no? S plus 1 whole square. Second slope. Oh, sorry, this is not 1 by 2. This is 2. I think when I'm writing, I have written it correctly, but so okay. We will meet tomorrow. See, Bode plots is, I think we have done. So that is what actually, so basically we'll identify the corner frequencies before the corner frequency one slope, after the corner frequency one slope. What is meant by corner frequencies? See, frequency at which the graph changes the slope is the corner frequency.